Singapore Mathematical Olympiad SMO 2021 open section round 1. We want to solve all the problems. If we use some basic ideas, I will prove some of them, but we will ignore the proof of some other theorems. If you had any question, any problem uh, with these ideas or from the problems of other years, 2020, any parts round 1, round 2, if you had any problem, feel free to send message to my WhatsApp number, subscribe my YouTube channel and turn on the bell to have next videos. Here they say in this paper, let R denote the set of all real numbers. It is floor of x and the greatest integer not exceeding x, and this is CL of x denote the smallest integer not less than x. Floor of 5 is 5, floor of 2.8 is 2, and floor of negative 2.3, because negative 2.3 is what is between negative 3 and negative 2.3 is between negative 2 and negative 3. So if you consider floor of that floor, he is here always, CL is this. And if you have integer, for example, floor of this is negative 3, floor of CL of that is also negative 3. And CL of negative 2.3 is, as I said, is negative 2. And let me just erase this part. Problem number 1 says it is given that beta is greater than pi over 2 less than alpha less than 3 pi over 4, cos alpha minus beta is 12 over 13, and sine alpha plus beta equals negative 3 over 5. Find floor of absolute value of 2021 times sine 2 alpha. So at first we draw a unit circle to consider alpha, beta, alpha plus beta, alpha minus beta. It says beta, we can consider it is 90, it is 135. So if I want to show 135, it will be exactly this point, 135 or 3 pi over 4. Alpha is greater than beta, so for example, beta is here, greater than 90. It is 90 degree, and alpha here. So alpha minus beta is greater than 0, less than, you can say 45. But here we only need 90, less than 90. Alpha plus beta is greater than 90 plus 90 equals 180, less than 135 plus 135, which is this. So we understand alpha plus beta is some point here, and alpha minus beta some point here. So when we want to find cos alpha minus beta, we know that we want to find sine alpha minus beta. Because alpha minus beta is in this place, so it is plus. So it will be plus square root of 1 minus this squared. Because sine of something plus sine squared of theta plus cos squared of theta. Theta here is alpha minus beta equals 1. If we simplify this relationship, we will have 13 squared 169 minus 144. Which equals 25 over 13 squared, which will be 5 over 13. For sine alpha plus beta, as you see, it is here, sine and cos is negative. So if we want to find cos alpha plus beta, then we will have negative 1 minus negative 3, 5 squared. If you simplify, it will be 25 minus 9, 16. So it will be 4 over 5 and negative sign here. Let me write better. Negative 4 over 5. So we found cos alpha plus beta, sine alpha plus beta, and cos and sine of alpha minus beta. Now we multiply cos alpha minus beta and sine alpha plus beta. It equals what? It equals 1/2 sine of sum of them, which will be 2 alpha plus sine this minus this. It will be 2 beta. And cos alpha plus beta sine alpha minus beta, it equals 1/2 sine of sum of them, sine 2 alpha plus sine this minus this will be sine plus sine negative 2 beta or negative sine 2 beta. So And we know the product of the first part equals cos alpha minus beta. If we add up these two things, it will be 12 over 13 times. It is cos alpha minus beta sine alpha plus beta negative 3 over 5 plus cos alpha plus beta plus negative 4 over 5 times sine alpha minus beta, which will be 5 over 13. Then sine 2 beta and negative sine 2 beta will be cancelled, and here we have sine 2 alpha. So sine 2 alpha equals exactly what? If we simplify, let's see. It will be 65, and here negative 36, negative 20, which will be negative 56 over 65. Now we should multiply 2021 and then absolute value and floor. 2021 times, because we consider absolute value, we can consider the positive. So at first we should multiply 2021 by 56. 6 times 2, 12, 1, 12. 5 times 1, 5, 5 times 2, 10, 1, 1, 5 times 2, 10, 6, 7, 1, 3, 1, 1. Then we divide it by 65 and want to find floor of that. So it will be 1131.76 over 65. So we say, okay, 1 times 65, 13, 8, here's 0, 10, 4, and now 481. We should have 7 here, and 5 minus 11, 6, 5 minus 7, 2. And then we take 7 here, and 4 here. This is 7, and 76. We have 1 here. So the answer is, and here 65, and you can see remainder is 1, 1. So the answer is 1741. Singapore Mathematical Olympiad Open Section Round 1, 2021. The problem says find the number of solutions of the equation absolute value of x minus 3 plus absolute value of x minus 5 equals 2. Note, if you think that there are infinitely many solutions, enter your answer as 999. In these types of problem, one important thing is to draw the function. After some problems, most of the times you can imagine the drawing, so it's one of the most important idea. We know the important points are 3 and 5, so x less than 3 greater than equal 3 less than 5, and x greater than equal 5. If x is less than 3, consider the left side. Suppose that, for example, y equals x minus absolute value of x minus 3 plus absolute value of x minus 5. We want to consider intersections of y, this y, and this, for example, equals to when y equals to. So for x less than 3, it will be 3 minus, let me write y equals 3 minus x plus 5 minus x, which will be 8 minus 2x. For this part, y equals, the first one is x minus 3, the second one is 5 minus x equals 5, 2, and in this part here you will understand, okay, for all x between 3 and 5 it will be 2, and there are real numbers, so you can say the answer is, we have infinitely many solutions. All real numbers greater than equal 3, also less than equal 5 is okay. So the answer is 99999. We finished, but let me just draw how we, for example, for some problems maybe we need, because it is very important in AMY problems for USA and also other national Olympiads, drawing is important also. Philippine round 1 qualifying level. The next one is x minus 3 plus x minus 5, which will be equal to x minus 8. And now we can say, okay, if we want to draw it, we can say 1, 2, 3, 4, 5, And for 3, the answer is what? The answer is 1, 2. So it is here 2, it is here 5. If you draw this, it will be something like, if I want to draw exact figure, also if x equals 0, you can say it will be 8. So it will be 8, something like this, with gradient -2 and also with similar gradient but positive. You will have something like this, and this point is 8, this point is 2, this point is 1. So all these points are our answers, all real numbers between 3 and 5. Singapore Mathematical Olympiad 2021, open section, round 1. Okay, evaluate 1 times 2 times 3 plus 2 times 3 times 4 plus 3 times 4 times 5 plus to 10 times 11 times 12. So let's copy this problem and solve it. One way for solving this problem is say, okay, the first one is 6, the second one 3, 6, 4, 24, and so on, and reach the answer. But maybe, for example, instead of 10, we had 100, so it was so much harder. Before solving this, let me tell you one of the most important identity. There are about sticks identity. There are around 15 important identities. If you want to know them, as I said, feel free to send a message to my WhatsApp number here and also description. Now, Hackett-Stick's identity says what? R choose R plus R plus 1 choose R, 2 R n choose R equals n plus 1 choose R plus 1. So here we can change. If we divide, let's consider this is a. If we divide a over 3 factorial, the first one will be 3 choose 3. The second one will be 4 choose 3. The third one will be 5 choose 3. And the last one will be 12 choose 3. If we use Hackett-Stick's identity, r equals 3 and n equals 12. So it will be 13 choose 4. So we can say, okay, a is what? 3 factorial times 13 times 12 times 11 times 10 over 4 factorial divided. Then we will have 4 here, 4, 3. Now we can say, okay, the first one is 39 times 11 times 10. 39, 39. If you do multiply by 11, it will be 12, 4. So the answer will be 4290. Singapore Mathematical Olympiad 2021 SMO, open section, first round, problem number 4. It is given that the solution of the inequality square root of 81 minus x to the power 4 less than or equal kx plus 1 is a less than or equal x less than or equal b with b minus a equals 2, where k is positive, and determine floor of k. So let's copy and solve this problem. Like one of the other problem we've solved, I said drawing diagram helps us. When you draw some diagrams after solving many problems, you can imagine many of them. So here we know 81 minus x to the power of 4 is inside the square root, so it must be greater than equal 0. So x to the power of 4 less than or equal 81. So x is less than or equal 81, greater than equal -3. Now, if you replace x with 0, it will be 81. Square root of 81 is 9. And then it will be 3. -3, let's consider this point 9. And this point, kx plus 1, it must be greater than this. For x0, it will be 1. And k is positive, so the gradient is positive, so it must be something like this, for example, this line. Or, for example, this line. Let's consider the problem says what? The answer is x only between a and b. So we know that it is between this and this, but what about this case? So we can see that if it intersects here, we have 2 answers. So because we have only one answer and we know it intersects here in some places like this, so we should consider that it must be something like this. And now it says, okay, This point will be A, this point will be B, so B is 3, A is what? A is 1, because B minus A is 2. So we understand what? We understand this is x equals 1 here. We understand in 1 they have intersection, so 81 minus 1 equals k plus 1. So k is what? Is the square root of 80 minus 1. Now we should do what? We should consider floor of this k. So floor of k equals this, because -1 is integer, you can take it outside. 81, it will be 8 point something, because 80 square root of 81 is 9, so it is less than that, and 80 is greater than 64, less than 8 squared, less than 9 squared, so square root of that will be 8 minus 1, so the answer is 7. Singapore Mathematical Olympiad SMO 2021 open section round 1 problem number 5. The figure below shows a cross that is cut out from a 10 by 9 rectangular board. Find the total number of rectangles in the above figure. Note, a square is a rectangle. So let's copy this problem and solve it. Each problem, most of the problems are based on some basic ideas. You have to know basic ideas, then by them they change something to that basic idea, and then you can solve it. The basic idea here is when you have a rectangle m by n, then if you want to see how many rectangles does it have, you should select the two vertical horizontal lines, two vertical lines. So it will be m plus 1 choose 2 times m plus 1 choose 2. Why m plus 1? Because, for example, when you have 2 by 3 table, you have 3. These 2 cells, but 3 lines. Also 2 by 3, here 4 lines. So we know it, the basic idea here is this. We want to use that to solve this problem. We consider different cases, because one case is that the vertical line is from these points, because then horizontal line cannot be this, they don't have intersection. The other one, let me draw with pink, the vertical line from pink ones. So if both of them are from blue, so you can say 1, 2, 3, 4, 5, 6, 6 choose 2, and the horizontal lines can be 1, 2, 3, 4, 5, 6, 7. 7 choose 2. The next one I draw with pink plus. If you select 1, 2, 3, 4, 5, 2 vertical lines from pink ones, so 1, 2, 3 horizontal line you can select, and also this horizontal line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 choose 2. Or maybe you select 1 pink, 1 blue. So you say I draw it with green. So 1, 2, 3, 4, 5. 5 choose 1 times 1, 2, 3, 4, 5, 6. 6 choose 1. Now horizontal line must be only from here. 1, 2, 3, 4, 5, 6, 7. 7 choose 2. So we should calculate these combinations. 6 choose 2 is 6, 5 over 6 times 5 over 2, 15. It will be 7 times 6 over 2, 21. Plus 5 times 4 over 2, 10. 10 times 9 over 2, 45. Plus 5 times 6 times 7 times 6 over 2, 21. So the first one, if you want to consider, it will be 21, 15, 15, and it will be 30. So 5, 1, 315. The next one is 450. The next one is 30, 0, 3, 6. So the last answer 0, 5. 3 plus 5, 8. 8 plus 1, 9. 6 plus 4, 10. 10 plus 3, 13. So the answer is 1395. Singapore Mathematical Olympiad 2021 SMO open section, first round, problem number 6. Consider all the polynomials p of x and y in two variables such that p of 0, 0 equals 20, 20, and for all x and y, p of x and y equals p of x plus y and y minus x. Find the largest possible value of p of 1 and 1. So let's copy this problem. When we see these types of problems, especially also in function, we can replace x, y with some numbers and see what we have. For example, p1, 1 equals here p2 and 0. Now we can say, okay, we know pxy is this. Consider this is a, this is b. So pab equals what? It is x here, so it is a minus b over 2, p of a minus b over 2, and y is what? Is a plus b over 2. So you can consider ab again as xy, p of xy equals x minus y over 2 and x plus y over 2. We know from here p of xy is this, so p of x plus y and y minus x equals p of x minus y over 2 and x plus y over 2. So if we consider this term CD, so we can say PCD equals P2D and negative 2C. Okay, so here we can say we want to find P20. P20 equals what? Equals P d is 0 here, 0, negative 2d is negative 4. Again, we use this. P of 2d, negative 8, and negative 2c, which will be 0, equals P of here, cd, 2d, 0, negative twice the first one, 16. And again, we can say, okay, it equals P of 2 to the power of here. Again, we can say 2d, 32, and negative 2c, which will be 0. So you consider this term, this term, this term. So we can write infinitely numbers like this twice each time. And after that, if we consider p of x 0 in general, it is only in terms of x. So it is, we can write in sigma, or we can say it is equal to an xn plus an minus 1 xn minus 1 plus a1x plus a0. The degree is n. And we can say, okay, we know what? We know that it is 0 for infinitely many numbers like this. You can write in general, you can write it and say, okay, p, for example, 2 of 0 is 0. P of, for example, 2 to the power of 5, 0 is 0. And you can easily prove that P of, for example, 2 to the 4k plus 1 and 0 equals 0. So infinitely many solution it has. Now we can conclude. And also you can use negative 8. You can find many infinitely many solution for this. So we know that if it has more than n roots, there are roots of this. So it is always 0. All coefficient will be 0. So P of x 0 will be 0 for all x. Oh, sorry. We said they are equal. Maybe they are not 0. So for example, consider there are constant. There are c. So always, so we know that because all of them are equal. So for example, all of them are equal c. So it is c. And we know all of them will be 0 and a0 equals c. So we know all of them are equal. Let me change it to p of x and 0 always equals c. And now we know what? We know, okay, p00 equals p11 equals p20. So p20 is what? Is c. And p00 equals also c. So we said it is 2020. So p11 equals 2020. SMO Singapore Mathematical Olympiad 2021 open section first round, problem number 7. In the three-dimensional Cartesian space with I, j, and k denoting the unit vectors along three perpendicular directions in a clockwise manner, the line L with equation given by r times I plus 2j plus 3k equals 5i minus 13j plus 7k. Here is cross product. Intersects the plane pi with equation x plus y plus z equals 16 at the point A, B, C. Find the value of a plus b plus c. Now, at first, we want to consider R. R is a line. For example, suppose R is D, E, F. We show it by this. Now, because R is a line, you can write all of them in terms of one variable. For example, E and F in terms of D. How we can find that, how we can show all of them in terms of one variable with this equation. So you say, okay, D, E, F for the first one, I, J, K, and the next line is 1, 2, 3. And now, if we consider cross product, the first one will be what? 3e minus 2f. The next one is f minus 3d, and the last one is 2d minus e. It equals what? 5, negative 13, and 7. So we write three equations, three variables here. 5, f minus 3d equals negative 13, and 2d minus e equals 7. Now, if we consider, for example, first one, e is 2d minus 7. We found e in terms of d. And if we consider this, f is 3d minus 13. So we can say our line is what? Our line L is the first one d, the second 2d minus 7, and third one 3d minus 13. Now we want to find what? Intersection of this line and the plane pi. So x plus y plus z must be 16. So d plus 2d minus 7 plus 3d minus 13 is what? Is 16. So 3d, 60 minus 20 is 16. So we can say 60 is 36. So d is 6. Now, the problem says, okay, intersection is a, b, c, a plus b plus c. So we found d is 6. So it will be what? 16 minus 7, 12 minus 7, 5. And 18 minus 13, 5. So a, it is b, it is c. A plus b plus c will be 6 plus 5 plus 5, which equals 16. So the answer is 16. Singapore Mathematical Olympiad 2021 open section first round. Problem number 8. Find the minimum value of x plus 7 squared plus y plus 2 squared subject to the constraint x minus 5 squared plus y minus 7 squared equals 4. For these types of problem, one of the most important way is to use Lagrange multiplier. If you want to know it is exactly what, and it is so much useful in SMO problems. If you wanted to know how to use that, feel free to send message to my WhatsApp number here and also in the description. Okay, so you consider G, this constraint, x minus 5 squared. You take all things to one side equals, if you pay attention also this in this problem, you can learn what is Lagrange multiplier. So take all to one side, so g equals 0. It is our constraint. Now f is what? F is our function that we want to find minimum or maximum of this. If it don't have constraint, we can use differentiation. But here when we have constraint, we use this and then we say, okay, L equals f minus lambda g. And it will be what? It will be x plus 7 squared plus y plus 2 squared minus lambda x minus 5 squared minus lambda y minus 7 squared. Look, you can also prove this problem with other ways, but why Lagrange multiplier is good? Because it is so much general. And for example, you can solve this problem with one idea, another problem with other idea, but in the exam, if you know this general idea, you can solve many problems of that. So at first you check this. Is it useful? Also in 2020, you use Lagrange multiplier. Also in 2021, we solve more than one problem with Lagrange multiplier. So this idea is so much useful. Now, it will be plus 4 lambda. Now, if you differentiate with respect in terms of x, let's say it will be what? 2x plus 7 minus 2 lambda x minus 5 equals 0. The next one, if you differentiate from y, it will be 2y plus 2 minus 2 lambda y minus 7 equals 0. Now, here we want to write what? We divide by 2, lambda equals x plus 7 over x minus 5. Maybe someone asks, why if x equals 5 and denominator will be 0, what happens then? If x equals 5, then we have what? Here, 5 minus 5 is 0. 5 plus 7, 12. 2 times 12 is not 0. So x is not 5. Here also, similarly, you can say it's y plus 2, y minus 7. Again, if denominator is 0, means y is 7 here. So it is not 0. So we don't need to consider those cases. Now we know lambda. From each case we can consider lambda. So we know x plus 7 over x minus 5 equals y plus 2 over y minus 7. If we cross multiply, we will have xy negative 7x plus 7y negative 49 equals. So let's check 7y negative 7x equals xy minus 5y plus 2x minus 10. So xy will be cancelled and 7y, 5y, 12y and equals 49 minus 10, 39, 7x plus 2x plus 9x. So if we divide both sides by 3, 4y equals 13 plus 3x. We know that we had a constraint. The constraint was what? The constraint was this, that x minus, let me copy this part. Now we found a relationship between x and y, so we can do what? We can replace y with in terms of x and find x. So here we can say, okay, y equals 3x plus 13 over 4. And here it will be x minus 5 squared plus y, which is 3x plus 13 over 4 minus 7 squared equals 4. Now, we simplify x minus 5 squared equals plus negative 28. Let's write like this, 33x plus 13 minus 28. 13 minus 28 is 15. So negative 15. Let's write 15 negative over 4 squared equals 4. Now, if we multiply both sides, we want to find x. We can expand, but if you consider here it's x minus 5 squared. Also, you can say, okay, if we factor from 3, it will be 9 over 16 of x minus 5 squared equals 4. So we can say, okay, x minus 5 squared times what? 1 plus this will be 25 over 16 equals 4. And now we can say x minus 5 squared equals 4 to 64 over 25. So x minus 5 can be plus minus 8 over 5. So x equals 5 plus minus 8 over 5. Now we say, okay, x is 25 plus 8, 33 over 5. 25 minus 8 is 17, 17 over 5. So we should check these two cases in our function f. Most of the time, for example, one of them is minimum, one of them is maximum. So our f is this, which is like what when we find 2 points. For example, in one-dimensional case, you can say, okay, when you have something like this, for example, because we don't have boundary, something. For example, it is 0, it is 0, it is 0, it is 0. So you should check these 2 points. The function is this, and we know y is what? Y is 3x plus 13 over 4. Y is 3x plus 13 over 4. For the first one, if we consider, it will be 3 times 33. Let's check. 3 times 33 is what? 99. 99 over 5 plus 13 all over 4. So it will be 99 plus 65 over 4 times 5. These two numbers will be 4. 6 times 1, 64 over 4 times 5. The first one, which will be 41 over 5. And next case, if x is 17 over 5, it will be 51 over 5 again plus 13 over 4, which will be 51 plus 65. 5 times 4 here, it will be 6. 6, 1 this point, and 2, 36, 9, 29 over 5. So we have two answers. So let's replace. The first one, if we want to replace x plus 7, it will be 33 over 5 plus 7 squared plus the corresponding y for this case is plus 41 over 5 plus 2 squared. So it will be what? 1 over 25. The first one, 33 plus 35, which will be 868 squared, and plus 41 plus 10, 51 squared. Before calculating, let's also calculate for the second case when x is 17 over 5 plus 7 squared plus 40, the corresponding is 29. Is 29 over 5 plus 2 squared. So you can say, okay, 1 over 25. The first one is 35, 45, 52 squared plus 29, 39 squared. So because the problem says find the minimum case, the problem says here find the minimum value. So if we consider them, we say, okay, it is greater than this, it is greater than this, so it will be minimum, it will be maximum case. So for the minimum case, if we want to calculate that, it will be 1 over 25, and they have 3 in common, so it will be 9. Oh, no. It is not, there are multiple of 13. 13 squared, which will be 169. It is 4 times 13, so it will be 16 plus. It is 3 times that, so it will be plus 3 squared, which will be 9. So it will be 25 over 25. So the answer is 169. SMO Singapore Mathematical Olympiad 2021 open section first round problem number 9. Find the largest possible value of alpha 4 plus beta 4 plus gamma 4 among all possible sets of numbers alpha, beta, and this satisfies the equations alpha plus beta plus gamma equals alpha squared plus beta squared plus gamma squared equals 14, alpha cubed plus beta cubed plus gamma cubed equals 20. So when we want to consider this, we can do many things. For example, you can multiply this by this to reach alpha 4. You can raise alpha plus beta plus gamma to the power of 4. You can raise this to consider this squared, alpha squared plus beta squared plus gamma squared. Let's check some of them. I think I'm sure that it has more than one way to reach. For example, let's check one of them. Alpha squared plus beta squared plus gamma squared to the power of 4 is, let's call this one A, let's call this one B, let's call this one C, let's call this one D. So it will be what? It will be A plus 2 alpha squared beta squared plus alpha squared gamma squared plus beta squared gamma squared. So we need to find this. So if we want to find this, at first we know that if we raise b to the power of 2 alpha plus beta plus gamma squared, it will be what? It will be 14, and here we know it is 2 plus 2 times alpha beta plus alpha gamma plus beta gamma. So for example, I consider this e. So e is what? 2 minus 14 over 2 negative 12 over 2 negative 6. So alpha beta plus alpha gamma plus beta gamma equals negative 6. Now if we raise that to the power of 2, it will be alpha beta alpha gamma plus beta gamma squared. Let's consider this f. We know it is 14. 14 squared 196. So if we find f, the problem will be solved. Here, if you raise this to the power of 2, we know e is negative 6. So here it will be 36. It will be alpha squared beta squared and all of them plus f plus 2 times this 2 times, let me write alpha squared beta y plus alpha beta squared gamma plus alpha beta gamma squared. So you can say it is equal f plus 2 alpha beta gamma, alpha plus beta plus gamma. So alpha plus beta plus gamma is what? Is 2. F, we want to find f. So if we find alpha beta gamma, then the problem will be solved. When we have a sum of cubes, one of the most important identity is that alpha cubed plus beta cubed plus gamma cubed equals alpha plus beta plus gamma alpha squared plus beta squared plus gamma squared minus alpha beta minus alpha gamma minus beta gamma, and then plus 3 alpha beta gamma. So they will be what? The first equation here, it will be 20. Alpha plus beta gamma is 2. Alpha squared, it is 14. And minus this here, it will be minus e, it will be 6. So we can say what? Alpha beta gamma is 20 minus 2 times 14 times 6 all over 3. I'm sorry, here it's 14 plus 6. So it will be what? It will be 20. It's 20 negative 40 and over 3. For this case, let's check the things here. It will be 2 squared here. So I should write, let me correct this careless mistake. It will be 4 minus 14 over 2, which will be negative 10 over 2, which will be negative 5. So e here is negative 5, so let me correct this part. It will be negative 5, and here it will be 25. And now here I can say that this part will be 5. So I should correct this. This part negative 5 is 5, so 14 plus 5. You can say 20 minus, it is 19. 2 times 19 is 38. 20 minus 38 is negative 18 over 3, negative 6. Now let's calculate. We wanted to calculate what? We wanted to calculate a. We said, okay, so we found alpha, beta, gamma, negative 6. So because it will be, and let's write the rest of that with black, negative 6. So f 2 times negative 6, negative 24. So f will be 49 here. 24 plus 25, 49. F will be 49, and here it is 49. So 14 squared 196 equals a plus 2 times 49, which will be 98. So a equals what? 196 minus 98. And it will be 98. Singapore Mathematical Olympiad 2021 SMO open section first round. Problem number 10. If P is the product of all the non-zero real roots of the equation, this find floor of absolute value of P. Okay, here if you consider, if you want to simplify at first, it says non-zero, so we can consider x is not zero. So if we, let's write with blue. So if we consider all, if we want to simplify, or for example, raise both sides to the power of, let's check, 7 to the power of 63. So let's see what we have. We can say x7 plus 30x to the power of 5 to the power of 63, it will be 7. So x9 minus 3x5 to the power of what, 9. And then we can factor from x to the power of 5 to the power of 7, 35. It will be x squared plus 30 to the power of 7. And here, x to the power of 5, x to the power of 45. We can take it outside, and it will be x to the power of 4 minus 30 to the power of 9. Okay, so if we consider x squared as a, so, and cancel x from both sides, because x is not 0, you can divide both sides by x to the 35. It will be a plus 30 to the power of 7, a to the power of 5. Here, a squared minus 30 to the power of 9. When we have polynomial, the degree is greater than 2. Also, for other years, I told you, one of the most important things is to check some integers, or for example, half, something like this, plus minus 1. Here, with 30, we have this. If you check a6, here we have 36, here we have 36. So let's check if a is 6. Here we have 36, 6 to the power of 14. Here we have what? Here we have 6 to the power of 5, 36 minus 36 to the power of 9. Well, it will be 6 to the power of 14. Okay, so a6 has answer. So x squared is 6. So x is plus minus root 6. Now, maybe we have also another root. We should check. So if I copy this part, copy, and paste it here. Because x is not 0, I divide both sides by x. So if you divide both sides by x, divide by x. X when go inside this 9th root, it will be x to the power of 9. So it will be 1 over x squared plus 30 to the power of x to the 4. And here is equal to 7. X to the power of 9 over x power of 7 is x squared minus 30 over x squared. So consider this function inside is f, this function is g. Now we consider that we differentiate from f, so it will be what? It's x negative to the power of 2. It will be negative 2 x cubed minus 30 times x to the power of negative 4 to the 5. So it will be negative 2 x cubed minus 120 x to the power of 5. So here we can conclude if it is positive, if x is positive, it is negative, but it is positive, negative, negative. If x is negative, it will be positive. So if I want to draw this function, for example, suppose when inside this part is, as for example, we know here, so f in this part is strictly descending. Here f is strictly ascending because it is greater than 0. So if I want to draw, let me consider this is f1, this is g1. So because inside of that is f and it is descending for positive, for x positive, so it will be something like this. And for infinite x, it will be 0. And for negative terms, it is strictly ascending. So if you consider negative terms here, it will be something like this. So f will be this. Now we want to consider, it is f1, because if you consider 9th root, also it is this. If we consider, if we differentiate from g, here it will be what? It will be 2x plus 3 times 2x cubed. So it will be 2x plus 60 over x cubed. So here again, if we want to consider for x positive, it will be what? For x positive, it will be positive. For x negative, it will be negative. So here you can say also when f is strictly ascending, f1 is also that. So here also you can say, okay, in this case g is strictly, because it is positive, ascending. Here g is strictly descending. So if I want to draw g or g1, let's copy this part, g1, and here, so Control C, Control V. So I draw g1 with lag. So if you consider x goes to positive infinity, it will go to positive infinity. And you can say for positive, it is ascending. So, and for 0, it will be negative infinity, less, near 0. It will be something like this. And it is ascending for this part. For x negative infinity, it will be positive infinity, and for near this, it will be this. So the function will be like this, because here g1 is ascending. So the answer of this, we found that it was what? Root 6 plus root 6. So it is the case plus root 6. They see each other in this point, and after that, g1 is ascending, strictly ascending, f1 is strictly descending, so they don't meet each other again. And also this point will be negative root 6. So we proved there are only these 2 points that are roots of our function. So the answer was product of real non-zero roots. Negative root 6, root 6, and also I think it was absolute value floor of that. Let's check. Yes. So you should consider absolute value floor because it is integer. It is exactly the same number. It will be, the answer will be 6. SMO Singapore Mathematical Olympiad 2021 open section first round problem number 11. Let S be the sum of a convergent geometric series with first term 1 if the third term of the series is the arithmetic mean of the first two terms. Find floor of 3s plus 4. Here, when we have one of the most important thing is memorize this identity. There are around 5 important identity. One of them is this 1 plus r squared to r to the power of n is rn plus 1 minus 1 r minus 1. Or usually for r less than 1, they write like this, for example, absolute value of that. Here, when suppose the first element is 1, the second element r squared r cubed to infinity, and it says convergent geometric series S is 1 plus r squared plus r cubed. There are around 4 more identities. If you want to know them, as I said, feel free to send message to my WhatsApp number here. Now we know it is equal because r must be, and because it is convergent, r must be less than 1. So the power of infinity, if you consider, it will be 1 minus r. The first thing we know is this, and first term is 1, so it is exactly our sequence. If the third term of the series is the arithmetic mean of the first two terms, so third term is arithmetic mean of first two terms, it will be this. So 2r squared minus r minus 1 is 0, so you can say r is negative b plus minus 1 plus 8 over 2a, which is 4. It will be 1 plus minus 3 over 4, which will be 1, and negative 1 over 2. Because it is convergent series, so absolute value of r is strictly less than 1, so it is right. So r is negative 1 over 2, and then problem says, okay, 3s plus 4, floor of that. So at first we should find s. S is 1 minus 1 over 1 minus r, which will be 1 over 1 plus 1 over 2, which will be 3 over 2, and it's 2 over 3. So 3s plus 4 will be 2 plus 4. So floor of that, because it is integer, is exactly this 6. So the answer of this problem is 6. SMO Singapore Mathematical Olympiad 2021 Open section first round, problem number 12. Given that sine alpha plus sine beta equals 1 over 10 and cos alpha plus cos beta is equal to 1 over 9, find floor of tangent squared alpha plus beta. So for solving this problem, we want to change sum to product. Sine alpha plus sine beta, if we want to change it to product, 2 sine alpha plus beta over 2 cos alpha beta, alpha minus beta over 2. Cos alpha plus cos beta equals 2. This one will be cos alpha plus beta over 2. Cos alpha minus beta over 2. We know it is 1 over 10 because it is this. It is 1 over 9 because cos plus cos is 1 over 9. So we want to find tangent alpha plus beta. If we divide these two terms, then we will have tangent alpha plus beta over 2 will be 9 over 10. We know a formula about tangent. Tangent 2 theta is 2 tangent theta 1 minus tangent squared theta. So tangent here it's alpha plus beta over 2. Tangent alpha plus beta is 2 times that, 9 over 5. 1 minus 9 over 10 squared, which will be this. And if we simplify, it will be this. 100 minus 81 is 19 over 100. It is 520. It is 9 times 20 is 180 over 19. Now, here the problem says consider this squared and consider floor of that. So we should raise that to the power of 2. 180 squared, it will be, as I said, memorize square until at least 30. 18 squared is 324. 2 zeros, it is 361. So we should divide to find floor of that. 361. So the first one, 3 to 9. If you consider 9, it's it's a little greater than this. So we should consider 8 here. 8 times 1, 8. 8 times 6, 48. 4, 8 times 3, 24. With 4, 28. If we subtract, it will be 2. And 3, 13. 5, 1, 11. 11, it will be 3, 5, 2, 0. And now here, if we want to find, it will be 9. 9 times 1, 9. 32. And you don't need to calculate this. I want to check remainder. I want to calculate to check the remainder is less than this to make sure. 9, it is a 1, and 11 minus 4, 7. 4 minus 2, 2. So it is 271. So it is 89. The remainder is this. So because we want to consider floor, so the answer equals 89. SMO Singapore Mathematical Olympiad 2021, open section first round, problem number 13. Determine the number of positive integers that are divisible by 2021 and has exactly 2021 divisors, including 1 and itself. Okay, the problem should say positive because the answer when is not positive, when the problem doesn't say positive, it is twice the number of positive divisors, but because it is 2021, it means that the problem means positive divisors. So 2021 is what? If you prime factorize, it will be 43 times 47. Now the number is multiple of 2021, so it is what? It is 43 times 2021k multiple. 43 times 47 times k. Now, we know it will be 43 to the power of alpha times 47 to the power of beta times another prime numbers, p1 to the power of alpha 1 to p, for example, s to the power of alpha s. We know alpha plus 1 times beta plus 1 times alpha 1 plus 1 to alpha k plus 1 its number of positive divisors. It's the formula of that. And also for sum and product, we have formulas. If you want to know why the formula of positive divisor is this, or had any question, as I said, feel free to send message to my WhatsApp number. Also, my WhatsApp number is in the description. Now, it is what? It is 2021 because of this. 43 times 47. We know alpha is at least 1, beta is at least 1, so it is at least 2, it is at least 2. So we conclude that all of them should be 1 because their product is 43 times 47. So one case is that it is 43, it is 47, and or it is 47, 43. So alpha plus 143, beta plus 147. The other case is alpha plus 147, beta plus 143. So for this case, our number will be 43 to the power of alpha 42 times 47 to the power of beta, which is 46. For this case, it is 43 to the power of 46 times 47 to the power of 42. So how many numbers do we have? 2 numbers. So the answer equals 2. SMO Singapore Mathematical Olympiad 2021 open section first round problem number 14. Let S be sum of 100, choose 4k from 0 to 25 minus 2 to the power of 98. Find floor of absolute value of S over 2 to the power of 48. Now, if we write this number, we will see that for this part, we want to analyze this part. It will be 100 choose 0 plus 100 choose 4. 100 choose multiples of 4 plus 100 choose 100. It equals a, we consider it equals a 0. The other ones 100 choose 1. Let's see what thing we don't have, because sum of all subsets will be 2 to the power of 100. So if I consider 100 choose 1 plus 100 choose 5 plus to 100 choose the numbers that their remainder when divided by 4 is 1. 97, we call them A1. 100 choose 2 plus 100 choose 6 plus to 100 choose 98 equals A2. The next one, 100 choose 3 plus 100 choose plus 7 plus 100 choose 99. We consider it is equal to A3. Now, we know A0 plus A1 plus A2 plus A3 equals 2 to the power of 100. The first thing we know. The next one, we know sum of the number of subsets with odd elements equal the number of subsets with even number of elements. The reason is this. It will be 100 choose 0 minus 100 choose 1. You should know binomial a theorem for this part, plus 100 choose 100. So by these things we can conclude, okay, A0 plus A2 equals A1 plus A3, and because sum of all of them is 2 to the power of 100, so each of them is 2 to the power of 100 over 2, which will be equal to the power of 99. And now we want to find another relationship. One thing, for the rest of that, we should work with complex numbers. Let me tell you something about complex numbers, and it's useful also in AME problems and in summer programs of some universities. For example, Ross program, this idea was used for 2022. When you consider these, and suppose the length of this is t, so if you want to show this point, it is te to the power of I theta is Euler's number. Now, and for example, if you raise this to the power of something, ei theta to the power of, for example, k, it will be tk ei theta k. So the angle of the result will be, for example, something like, let me draw with pink. It will be something like that, and the length will be t to the power of k, and this angle will be theta k. So now let's consider 1 plus I to the power of 100. We know I is what? Square root of negative 1. So I squared is what? Negative 1. I cubed is what? Is negative I, and I to the power of fourth will be positive 1. I to the power of 5 will be I. So the period is what? Is 4, and that's the reason here we need that. So you say 100, choose 0, we don't select I, plus 100, choose 1, we select I once, minus 100, choose 2, because I squared is negative 1. The next one, minus 100, choose 3I, plus 100, choose 4. And as you can see, this is our number. Now, 1 plus I shows what number? 1 plus I is 1 here and 1 here. So if you consider, and this, it will be what? It will be 45. And here 1 plus I will be, this length is root 2. 1 plus I is root 2 e to the power of I 45, or we can say pi over 4, because pi is 180 over 4 is 45. Now the left hand side will be root 2 ei pi over 4 to the power of 100. It will be 2 to the power of 50 e to the power of I 25 pi. 25 pi is equivalent to pi, so it will be negative 2 to the power of 50. If you want to more explanation of these things, complex numbers, something like this, as I said, feel free to send message to my WhatsApp number here, and also it is in the description. Now, we conclude what? Negative 250 equals 2 to the power of 50. Equals what? Equals the real part of here. It will be what? It will be a0 minus a2. And also we concluded that imaginary part is 0. Imaginary part is a1 minus what? Minus a3. So let's write down the things that we've reached so far. a0 also plus a2 we said is a1 plus a3 equals 2 to the power of 99. Here we've reached this part. Now the number of even subset with even elements, here the number of subsets with odd number of elements. Now we want to find a0. So let's write a2 in terms of a0. a2 is a0 plus 2 to the power of 50. If we replace here a0 plus a0 plus 2 to the power of 50 equals 2 to the power of 99. So we can conclude 2a0 equals 2 to the power of 99 minus 2 to the power of 50. So a0 is what? Is 2 to the power of 98 minus 2 to the power of over 249. Now the problem says what? Consider, let's see, the problem says find a0 minus 2 to the power of 98. So we should calculate this to the power of 98 over 2 to the power of 48 absolute value, and then consider floor of that. We should calculate this. So let's copy this part. Control C. So here minus 28, it will be absolute value will be 2 to the power of 49 or 2 to the power of 48, and this will be 2, so it will be negative. I ignore negative because we have absolute value. After we consider at first, look, absolute value 2, and then it will be 2. So the answer of this problem equals SMO Singapore Mathematical Olympiad 2021 open section first round problem number 15. Assume that ABC is an acute triangle with sine A plus B equals 3 over 5 and sine A minus B equals 1 over 5. If AB equals 2022 bracket root 6 minus 2 close bracket, determine floor of H where H is the height of the triangle from C on A. Okay, we call this one H, and for example it is a C, for example C prime. So if we want to consider each of them in terms of h, so tangent A is h over this term. Tangent A is h over AC prime, so you can say AC prime is h over tangent A. So this part is h over tangent A. Similarly, this part is h over tangent B. We want to find h, so we know that h over tangent A plus h over tangent B equals AB, which we know that is 2022 times root 6 minus 2. So our goal is to find a 1 over tangent A plus 1 over tangent B. If we find this, then we factor from h here and you know here, so we can find h. It will be what? It will be tangent. If we write, let's write tangent A is sine A over cos A. We write cos A here. 1 over tangent B is cos B over sine B. So if we use common denominator, it will be sine A sine B cos A sine B here plus sine A cos B. Now, if we consider the numerator equals sine A plus B, and now the denominator equals cos A minus B minus cos A plus B, because we have here cos A cos B, minus will be plus sine A sine B. Here it will be cancelled, and you should consider 1/2 of this. Now, sine A plus B is good because we know it is 3 over 5. And 1 over 2, we should find cos A minus B, cos A plus B. A plus B, because it is acute triangle, C is less than 90, so A plus B is greater than 90. So cos A plus B is negative, and this squared plus this squared equals 1. So it is negative 1 minus 3 over 5 squared, which will be 9 over 25. If you simplify 25 minus 9 is 16, negative 4 over 5. So we found the first part, negative 4 over cos A plus B it was. So here it is negative 4 over 5. We know sine A minus B is 1 over 5. So cos A minus B is what? We know that A minus B is sine of that is also positive, so it is between 0 and 90 degrees because it's a acute triangle, so cos of that is also positive. So it will be 1 minus this squared, negative 1 over 25, so it will be 24 over 25, which will be 2 root 6 over 5. Now let's replace here cos A minus B. We proved that it is 2 root 6 over 5. Now if we cancel, let's consider 1 over 2. 1/2 of this will be root 6 over 5. Here is plus 4 over 2 is 2, 2 over 5. We can cancel this 5, so it will be 3 root 6 plus 2. Now, we can say what? H times 3 over root 6 plus 2 equals 20 root 6 minus 2. Now, if we cross multiply and h here, it will be 20, or we can say multiply both sides by root 6 plus 2 and divide both sides by 3. It will be 6 minus 2. It is 4, and if we divide by 3, it will be 6, 7, 4 times 4, 4 times 4, 16. 1, 4 times 7, 28, 29, 2, 4 times 6, 24, 26. So h is this, and the problem says what? Find floor of h, which is this. So the answer is 2696. I've made a careless mistake here. It's 6 minus 2 it was. Because the problem says it is, let's check it, root 6 minus 2, not root 2. So it is this. So when we check this, it will be 6 minus, let's just correct this part. It will be 6 minus 4, 2. And now it will be multiplied by 2. 2 times 4, 8. 2 times 7, 14. We have 1. 2 times 6, 12. 13. So the answer is 1348. SMO Singapore Mathematical Olympiad 2021. Open section first round. Problem number 16. Let A1, A2, and dot 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 be a sequence with a1 equals 1 and an plus 1 equals n plus 2 over n times s, and for all n equals 1 2 dot 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 where sn equals a1 a plus a2 to an, determine the minimum integer n such that an is at least 2021. Okay, so let's replace and consider, as I said, one of the most important idea is considering small examples. So a2 is what is here. Let me write like this. An equals n plus 1 over n minus 1 Sn minus 1, which means that n plus 1, n over n minus 1, a1 to an minus 1. So a2 is what? Is 3 over 1 times the previous one, 1. So a2 is 3. a3 is what? Is 4 over 2 times sum of previous one, 3 plus 1, which is 4, 4 over 2, 2, 4 times 2 is 8. Now, a4 is 5 over 3 times the previous one, 8 plus 3 plus 1. So 11 plus 1, 12, 12 over 3, 4, 5, 4 times 5, 20. The next one, a5 is what is 6 over 4 times 20 plus 8 plus 3 plus 1. Here it will be what? As you can see, each term the next one is greater than twice the previous one. So we can easily reach 2021. If we check, it will be what? It will be 3 over 2, 28, 31, 32, which will be 16. 3 times 16, 48. A6 is 7 over 5, the sum of previous ones. So here, look, sum of previous ones here, sum of all of them is 32, so you need to add only 48. So after writing something, you can learn and solve easily when you consider a small example. You can find some pattern. 8 plus 2, 10, 4, 3, 7, 80. 80 over 5 is 16, and it will be 1, 1, 12. And if you want to find a7, it will be 8 over 6 times 80 plus 1, 1, 12. And it will be 8 over 6 and 2, 8 plus 1, 9, 1, 9, 2. It will be 8, 3, 12 over 6, 32. It will be 16, 2, 5, 6. Now, I think after around 2 or 3 steps or 4 steps, we will reach the end we want. A8 is what? 9 over 7. And 9 over 7, n plus 1, n minus 1 times 192 plus 256. So if we add these two numbers, it will be 8, 5, 9, 14, 4, 4, 8. So it will be 9, 6, 4. It will be 6, 5, 7, 6. And the next one, A9. If we want to calculate A9, it will be what? It will be 10 over 8. 4, 4, 8 plus 5, 7, 6, which will be 10 over 8 will be 5 over 4. And 8 plus 6, 14. We have 1. 7, 4, 11, 2, 1, 5, 4, 9. It will be this. So it will be this. 28, 2, and it will be 1280. And if we consider A10, it will be 11 over 9 times 1, 2, 80. This one plus the previous ones. 10, 24, it's 11 over 9 times 4, 2 plus 8, 10. We have 1, 0, 3, 1, 1, 2. So if we divide by 9, it will be 2, 5, 6. And if we multiply 2, 5, 6, 2, 5, 6, 6, 11, 8, 2. So 8, 10 is 28, 16. Now let's see the problem once exactly. What determine the minimum integer n such that an is greater than equal 2021? So the first one is 10, so n equals 10. So the answer of this problem equals 10. SMO Singapore Mathematical Olympiad 2021 open section round 1. Problem number 17. Each card of a stack of 101 cards has one side colored red and the other colored blue. Initially, all cards have the red side facing up and stacked together in a deck. On each turn, Allame takes 8 cards on the top, flip them over, and place them to the bottom deck. Determine the minimum number of turns required so that all the cards have the red sides facing up again. Okay, so for example, suppose that we write in one line, this top is from here. At first, all of them are red. And it says we have red or blue. Now, in the first case, we have 98 and 101R. Now, you consider 8 of them, change it to blue, then you have R, and 8 blue here. So here you have 8, and 101 minus 8 is 93. Then you select 8 of them again, change them to B, and here you place them to the bottom. So the next case, it will be the number of R will be 93 minus 8, which will be 85, and the number of blues will be 16. If you write down after 12 steps, because 12 times 8 is still less than 101, so you have 8 times 12, 96b. And how many R we have? We have 5 R's. Then you do what? You change, because it is not one step, half a step. You change them to B and 3R. And then all of them B. How many B we have? 93. And then place them to the bottom. So here we will have, so it is on one step. So we have B, because you place this part to the right hand side to the bottom. So B, 5B, and 93, 98B. And then you have what? 3 R's. Okay. And then for the next step, you consider 8B, change 8B to 8R, and then you subtract here by 8, you have 90B, and then the number of R's will be 11. So if I want to write, I say 101 R I have, then after 12 steps, I have 3R and 96B, like here. I have, 5R, 96B after 12 steps. After one step, then you place here 8 from here, 5 plus 3 here, change to R, this change to B. So you have 3R here, and then 98B. Again, you consider how many steps? 12 steps. You change 96B to 96R, then you have 2B and 99R. Then after one step, I change this to B to R, and because I select 8, so 6R to B, so you have 6B and then 95R. 95, you change them, it will be 95R and 6B. Let me explain, for example, this board. You have BB and then R, 1, 2, 3, 4, 5, 6, and then all of them are here. So you change these to what? To R, R, B, 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 5 B's. Yeah, let me check. 1, 2, 6 B's. 1, 2, 3, 1, 2, 3, 4, 5, 6. And then change them to R and then place them to the bottom. So you have 2R here. How many R do we have in this case? So you had 2 here and 6 here, 8, 100. We have 93 here. 93, we have when you place 93 and 2R, when you place it to the bottom, you have these 2R and 93R, 95R, and then 6B. So then after here, 12 steps, you can't say because 8 times 12 is 96 greater than this, but after 11 steps, you will change 88 of these, so 7R is left and 104, 94B you have here. Okay, now in the next, in one step, you change these to B and only one of them to R, so it will be R and 100 B. Let me, sorry, 100 B and 1 R here. Then in 8 steps again, you change 96 of them to R, so 4B is left and 97 R. Then in one step, you change 4B to 4B and 4R to 4B, so you have 4B here and 497R again. In the next steps, 12 is 8. Oh, sorry. Here I've written 8. I should write 12 steps because in each step I consider 8. And the rest of them is correct. Again, here you consider 12 steps. It will be what? It will be R and 100B. Then in one step, you change it to B and 7 of them to R. So it will be 7R and 94B. So in the next steps, vice versa, 94B here, because after that you place to the bottom, 94B and 7R. So again, after here, 8 times 11 steps. 88, it will be 6B, and here we will have 95R because all of them is 101. And then in one step, you change 6B to R, and here 2R to 2B, and 99R. Then in 12 steps, you have 3R, 96 is subtract 96 from these. And then you have 3R. How many B's do we have? 98B. Then in one step, you change 5 of them to R, 5R, 96B. Then in 12 steps, you will change all of them to R. So you have 100R. Now let's count in how many steps we've reached this. Okay. If I want to write 112, 212, consider also this is 12, 312, 4, 512, 612, 712, 812. So we have 812 times 12 plus. How many ones do we have that we've not counted? So here 1, 2, 3, 4, 5 plus 5. Okay, so it's 96 plus 5, which equals 101. So the answer. Okay, SMO Singapore Mathematical Olympiad 2021. Open section first round. Problem number 18. Let ABC be a triangle with AB equals 10 and cos A over cos B equals AC over BC equals 4 over 3. Let P be a point on the inscribed circle of triangle ABC. Find the largest possible value of PA squared plus PB squared plus PC squared. So at first, let's consider this equality. Cos A over cos B we know AC is what? AC equals, AC is B, BC is A, equals sine B over sine A, which equals 4 over 3 by the assumption of the problem. So if we cross multiply, we can conclude cos A sine A, and if, let me write that first here, cos A sine A equals cos B sine B. Now we can multiply both sides by 2, so sine 2A equals sine 2B. Now, there is an important formula that when you know that sine alpha equals sine beta, the general solution is alpha equals beta plus 2k pi, or alpha equals pi minus beta plus 2k pi. Or let's write in, we can write also in degree. You can say beta plus 30, 360 degree k, 180 minus beta plus 360k. Now, here we say, okay, 2a equals 2b plus 360k. So in this case, we conclude a equals b plus 180k. So because a and b are angles of the triangle, we conclude in this case a equals b. But in this case that a equals b, then sine a over sine b equals what? Equals 1. That's contradiction. In the next case, we say, okay, 2a equals 180 minus 2b plus 360k. If we divide by 2, a is 90 minus b plus 180k. So then we can conclude a plus b is 90 plus 180k. We know a plus b is less than 180 because there are angles of triangles. So k can only be 0. So a plus b equals 90. Now, we draw the triangle. Our figure is this. So we consider we want to maximize PA squared, PB squared, PC squared, and AB or C is 10. And we want to maximize PA squared, PB squared, PC squared, and the other condition is what? The other condition is B over A is 4 over 3. B over A is 4 over 3, so we can say B is 4x, A is 3x, and because we have this, we've proved that a plus b is 90, so c is 90. We have right angle triangle, and c squared equals a squared plus b squared, so c squared equals x squared 4 squared plus 3 squared, which equals 25x squared. So c equals 5x. Now, because we know c is 10, so x equals 2. Now we conclude what? B equals 4 times 2, 8, A equals 3 times 2, 6, and C equals 5. Now, we want to find this length. As I said in geometry, we have formulas that this length in general triangle is semi-meter minus this side, C. And the proof is in one line. If I want to say, you write this angle, this side equals this side, this side equals this side, and write equation, and you easily reach it's S minus C. If you want to know exactly the proofs or what, as I said, because there are some basic ideas, we use them in each problem. If you had any problem, as I said, feel free to send message to my WhatsApp number here. Now, let's consider the problem. So, at first we should find S, semi-meter. S is what? Sorry, C is 10, because it is 5 times 2, 10, and also here 10. S is sum of them over 2, which will be 10. So this one, S minus, let's check it again. Sorry, S is 10 plus 6 plus 8, 24 over 2 is 12. So 12 minus C is 2, 2, 12 minus B is 4, 4, and 12 minus 6 is 6. And now we found all these things. Now, the problem says find maximize or find largest possible PA squared, PB squared, PC squared. There is an important formula. As I said, there are around 50 important formulas in geometry. One of them is this: if P is an arbitrary point, PG squared is 1/3 of PA squared, PB squared, PC squared. minus 1. You should memorize this, and if you had problem with the proof, you can, as I said, feel free to send message to my WhatsApp number in the description. Now, we know, okay, a squared, b squared, c squared, we know it's what? Why? Because a squared is 36, b squared is 64, c squared is 100. So ba squared plus bb squared plus bc squared is what? Multiply. At first consider it is 100. 200 over 9. Multiply both sides by 9. Then it will be 9pg squared plus 200 and all over 3. So if you want to maximize pa squared plus bb squared plus bc squared, you should maximize pg. And now we know that p lies on the circle and g is a point. So if you want to maximize a point, it has proof. You should connect p to the center of the circle. If you want to find p, let me tell you. You should connect gi and the intersection here. Because if you want to find the maximize pg, p is here. If you want to minimize pg, p is here. It has proof. You can easily prove it by triangles inequality. Again, for also proving this part, you can send message to my WhatsApp number in the description. Now, let's we want to focus pg squared. Pi is r, and there is a formula. R is equal to area ABC over semi-meter. Area here is what? Is A times B over 2 over S. So AB over 2 is what? AB over 2, 3 times 8, 24 over 12. It's 2. So R here equals 2. And now we want to maximize, here we wanted to maximize P is this point. And PG is what? PG is PI or in radius plus IG. So PG equals in radius plus IG, maximum PG, and it equals 2 plus IG. So we should find IG. Again, as I said, P was an arbitrary point. You can say IG squared equals 1/3 of IA squared plus IB squared plus IC squared minus 1 over 9 of A squared plus B squared plus C squared. Now, if we find IA, IB, IC squared, then the problem will be solved. Let me copy this figure and find IA squared, IB squared, IC squared. So here, let's erase the thing that we don't need in this part. So here, if I want IB squared, it is what? It is R squared plus this. IA squared, also IC squared. So let's calculate each of them. It is 2, it is 2. So the first one, IA squared is what? Is 2 squared 4 plus AD squared 36. IB squared is 16 plus 4. IC squared is 4 plus 4. Now, we can say it is 1/3 of 40 plus 20 plus 8 minus 1 over 9 of sum of them. It will be 64 plus 36 plus 100, which equals 200. Now, it equals, this part is 68. So, it is 1 over 9, 3 times 68. Let's see, PG squared 2 plus IG. So we should find IG and then replace here to calculate. So it equals what? It equals 3 times 68 minus 1 over 9. Or we factor from 1 over 9, it will be minus 200. So it will be 1 over 9. 2 minus 200. Now we found IG is 4 over 9, square root of that is 2 over 3. Now, if we replace here, let's write the rest of that by black. 2 plus 2 over 3, which equals 8 over 3. So maximum PG is this. And if we replace here, 9 times this squared, 9 will be cancelled. 64 plus 20 over 3. 264 over 3, which will be 88. So maximum PA squared plus PB squared plus PC squared equals 80. SMO Singapore Mathematical Olympiad 2021 open section first round. Problem number 19. A basket contains 19 apples labeled by the numbers 2 to 20 and 19 bananas labeled by the numbers 2 to 20. Allame picks M apples and N bananas from the basket. However, he needs to ensure that for any apple labeled A and any banana labeled B that he picks, A and B are relatively prime. Determine the largest possible value of Mn. Okay, so let's consider the labels. We know that even numbers, all of them, if you consider each pair, they are not co-prime, relatively prime, because 2 divides both of them. So let's consider 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And we can say, okay, 3 is related to 6, to 12, to 18. Also, we can say the next one, 5 is related to, let me write like related to 10 to 20, and 15 is related to all these numbers on 3 and 5. So we want to show it with a better diagram. So one good way to show them is this. For example, draw 3 circles. Let me draw with these 3 circles. How we can say, okay, these are multiples of 2. Let me draw also another circle. It is 2, 4, 8, 16 here. Now we consider, for example, there are multiples of 3 here. 2, 3, 6, 4, 5. We consider 5 here. 6, 7, 2, 3, 4, 5, 6, 7. We consider 7 here, so 14 here. 7, 8, 9. 9 is here. 10. 10 here. 11. It is relatively prime to all numbers, other numbers. 12 here. 13 here. 14, 15 here. 16, 17, 18, 19, and the last one, 20. Now, let's consider one thing at first. 2, we should select 2, 4, 8, 16 for at least one of them. Why? Because, if, for example, we don't have any even number, okay, if we don't have any even number, let's see what we have. So if we don't select even numbers here, all of them, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we don't have any even number, then 3, 4, 5, 5 plus 9. So 9, the product is at most 4 times 5, which is at most 20. We will reach greater numbers. So we can say, let me at first tell you an example that is good. But before considering that, let me tell you all the cases. For example, I say this part is 1, this part is 2, this part is 3. So if I select, for example, I want to split the numbers into 2 parts. Let me at first tell you, you can find some example. For example, one of them is what? You say, okay, I have all even numbers in one case. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, and also I can consider all numbers here. 10, 11, 12, 13, 14, 15. So 15 times 4, it's 60. So we've reached 60. The answer is greater than equals 60 because it's maximum. So it is 60 or greater than that. So if we don't have any even number, the answer is at most 20. So we have even numbers. And if we have even numbers in one case, so all even numbers, if you want to have here, all of them are odd because they must be relatively prime. So we should select 2 here because we don't have any problem if we select 2 here, because 2 has only 2, and though, for example, 6 maybe for 3 we have problem here. But if you have even here, you select 2, 4, 8, 16. So we always select, if we want to maximize Mn, the product, we always select 2, 4, 8, 16. So we should decide on these parts. Part 2, 6, 12, 18, all of them has only 2 and 3. If we select, for example, 6 in one case, in one for apple or banana, we can select 12 and 18 for that part because they have only 2 and 3. It doesn't have any difference between them. 20, 10 also, and 14. So we consider cases that we select 1, 2, or 3. So 1, 2, and 3. So if we select all of them, if we select only 1 and 2, if we select only 1 and 3, if we select only 2 and 3, if we select only 1, if we select only 2, if we select only 3, and if we don't select any of them, in each case we want to find the maximum case. So let me just copy this and minimize so we can calculate. Control V, a little smaller, and here, okay. So the other numbers that we have, 11, 13, 15, and no, 15, not 17 and 19. So if we select 1, 2, and 3, so we have all of them in one case, for example, one part. So 3, 9, 15, all of them we place in that part to maximize. Here it will be at most 15. Here we have 15 times 4, 60. Now, if we don't select 3, for the back that it means that when we don't select this part, because if we select, we know 2, 4, 8, 6, then we have here. If we don't select here 20 and 10, because if we had 20 and 10, they were in this case in A, for example. If I call this A and B, we should select in A because they are not relatively prime to this back. And now let's see, we don't select 3, so in A we have what? 1, 2, 3. If we select 14, so we select also 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will be 11 times. Because we don't select 20 and 10, we don't select 15. Because if we, let's check, if we select 15, let's see, do we have any problem or not? If we select 15 here, then we can't select any of this part 2 here, 6, 12, because 15, we want to select, we said what? The elements in 2 columns in A. So we can't select 15. So we can say what? Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And for the other case, we can only select 5 and these parts. 1, 2, 3, 4, 5. And it will be 55. Now let's consider this case. 1 and 3, we don't have 2. We don't have 2, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It is at most 9. For the other part, because we don't have 2 here, for the other part, we can select 3, 9. 1, 2, 3, 4, 5, 6. 9 times 6, 54. And in this case, when we don't select from 1, we say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. The rest of that you can select 1, 2, 3, 4, 5. 5, 65. We've reached greater than 60. Now, the next case, if we select 1 only, so 1, 2, 3, 4, 5, 6, 6. And for the other parts, you can select here 1, 2, 3, 4, 5, 6, 7, 8. It will be 48 if we only select from 2. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9 times because we only selected 2. So the other parts 1, 2, and 4, 6. 54. And if we only select from 3, so 1, 2, 3, 4, 5, 6, 7, 7 times the other parts you can select for B 1, 2, 3, 4, 5, 6, 7. It is 49. And in the last case, if you don't select any of them, 1, 2, 3, 4, 4 times 1, 2, 3, 4, 5, 5 plus 4, 9, it will be 36. We've considered all the cases and we saw that the 65 is the greatest one. So the answer equals 65. If you had any question of how we proved this problem or also a question from other problem, anything, as I said, feel free to send a message to my WhatsApp number here. SMO 2021 Singapore Mathematical Olympiad open section first round problem number 20. Let p of x equals ax squared minus bx plus c be a polynomial where a, b, c are positive integers and p of x has two distinct roots in 0, 1. In interval open 0 and 1 open interval. Determine the least possible value of a, b, c. Okay, so let's consider, because a is our positive integer, a is positive, so it opens up. Now, as I said also for some of the previous problems, you should consider the diagram. Sometimes you can imagine also at first you should solve some problems, then you can imagine. Also in many AMI problems for USA, for Philippines, for all national countries, you need to draw a diagram like this. A is positive, it opens up because we have two roots. It will be something like this. So we have something like here. Okay, so at this point is when x is 0, so it will be c. And this point is when x is 1, so it will be a negative b plus c. And we can say they are positive. C is positive, a negative b plus c is positive. And also we have two real roots. So two distinct roots in this interval. So discriminant is strictly positive because two distinct roots. So we can say b squared minus 4ac is greater than or equal 0. Here also we conclude b is less than a plus c. So we say b squared is greater than or equal 4ac. Because it is strictly positive, strictly greater than 4ac and less than a plus c squared. So we say, okay, because we want to find minimum ABC, you consider from, for example, the case if AC is 1, then a plus c is 1, 1 is 4, b squared less than 4. We don't have any choice. If AC is 2, so b squared is greater than 8, less than a plus c. You have the case 2, 1, so 3, 9. We don't have any choice here. If AC is 3, you check. So let me tell you, for general AC, you should do what? If AC is k, you can say b squared is greater than 4k, less than a plus c squared. If I want to say the minimum case, for example, for AC when equals 4, you can say it is 4, 1, or you can say 2, 2. So if we consider 4, 1, it will be greater than the sum of them, greater than this. So if AC is constant, if A and C are far from each other, then A plus C is maximum. So it is less than, the maximum case is this. Now, if we consider for AC equals 4, it will be 16, it will be 25. We don't have any choice. If we consider AC 5, B squared greater than 20, less than 5 plus 1, 6, 36. So B can be 5. So in this case, ABC is what? ABC is 25. So you can check also for the other case. If you check, for example, if AC is greater than this, AC is 6 or other things, then B squared is greater than 36. So B is greater than 6. If AC is greater than or equal 6, so ABC will be greater than 36. So The minimum case is 25, but we should check that. Is it possible or not? So let's consider our equation is what? Is ax squared minus bx plus c. Ax squared minus bx plus c. And for example, if we consider a1 and here c5, okay, a1, if we consider c5, let's check this one at first. X squared minus 5x plus 5. So if we consider the roots, it will be x 5 plus minus 25 minus 20 over 2. So it will be 5 plus minus root 5 over 2. So the roots here are not good. If we consider a5, 5x squared minus 5x plus 1 equals 0. Let's check this case. Then x is 5 plus minus 25 minus 4ac. It's minus 20 over 2a here. 10, it will be 5 plus minus root 5 over 10. So easily we can say 5 plus root 5 over 10 is less than 1, greater than 0. Why? Because 5 plus root 5 is less than 10, less than 0. It is equivalent. Here is obvious. Here is this is less than 5. So 5 less than 25, which is obvious. And this case, 5 minus root 5 over 10 is greater than 0, less than 1. So it is obvious that this is positive also for less than 1. We can say 5 plus this number is less than 1. So it is less than this. So both of them are less than 1. So we've checked that it is also possible. So A, B, C, 25 when A, the minimum case, A is 5, B is 5, and C is 1. The answer equals 25. SMO 2021 Singapore Mathematical Olympiad open section first round. Problem number 21. Okay, in the triangle ABCA is greater than 90, the incircle touches the side BC and AC. BC at A1 and AC at B1. And the line A1, B1 meets the extension of AB at X such that CXB is 90 degrees. Suppose that BC squared A squared equals C squared plus AB. Find the size of angle A. So if we use cos rule, we know A squared equals C squared plus B squared minus 2BC cos A. So if we consider they are equal, we can conclude AB equals, we can cancel C squared. B squared minus 2BC cos A. If we cancel B, then A equals B minus 2C cos A. So we want to find C negative C cos A. So if we extend CA and draw this perpendicular to this line, and let me draw also exactly here. So suppose that it is T, it is L. So it is 180. You can say it is B plus 2C cos 180 minus 8. And this length is C. C cos 180 minus A equals AT. So it equals B plus 2AT, which equals B plus 2AT. And we consider this is perpendicular and we've extended until reach L that AT equals TL because it is 2AT. And I said one of the most important idea is to consider extend. Sometimes we split, sometimes we extend. In one problem of SMO 2021, when we have sum of two lengths, in that case we split. The larger case here we extend. B plus AL. So B is AC plus AL is CL. So we proved that A, which is BC, equals CL. So these two angles are equal. Let's calculate. It is A. It is 180 minus A, and because it is this line, these two triangles are congruent by two sides and an angle between, so it is 180 minus a. It is also 180 minus a. Now, this angle equals what? This angle equals, the exterior angle is a, it is 90, it is a minus 90. So this angle also equals a minus 90. So BC equals CS, so this angle, the whole angle here equals this angle. So we can conclude 180 minus a equals 2 times a minus 90 plus b. Let's simplify 180 to a. 2a here and plus a 3a plus b negative 290. Take it to the left hand side. It will be plus 180 plus 180 will be 360 degrees. Now we want to do some angle chasing. Let's do it with, for example, black, this part. This angle is what? This angle is 90 because this is an isosceles triangle. It is C, so it is 90 minus C over 2 because well, sum of them is 180 minus C. If we want this angle, 90 minus C over 2. This angle is what? It is 180 minus A. So we found a relationship between A, B, C. We want to find this angle in terms of C. C is what? 180 minus A minus B. So here we found B in terms of A. B is 360 minus 3A. The first thing that's now 180 minus A minus B, which is 360 minus 3A. So if we simplify 3A minus A, 2A minus 360 plus A 180, it will be minus 180. Now, if we calculate this angle, it is 90 minus C over 2. So 90 minus C over 2 will be 90 minus A minus 90. So it will be 90 plus 90, 180 minus A. So we understand these two angles are equal, so we can conclude AA1CX is cyclic. Now let's copy this figure. Control C here. And we want to use this property. Let's erase the thing here we don't need. Okay. This part, this AA1CX is cyclic. Now, if we connect this AA1, we can conclude what? We can conclude, because it is cyclic, so this is 90, so it is also 90. We know what? AA1 is perpendicular to BC. Also, if we have I here, IA1 is also perpendicular to what? To BC. So we understand AI, A1, it is one line. Because it is one point, it is line. We don't have two perpendicular to this line. This is perpendicular to BC. Now, if we draw the correct figure, let's consider the new figure here. We say, okay, it is what? This point is I. Now, then this is altitude and also internal angle bisector. So easily we can prove these two triangles are congruent, and this is an isosceles triangle. So AB equals AC. So angle B equals angle C. Angle B was what? 360 minus A, 3A. Angle C was what? 2A minus 180. So we can conclude what? 360 plus 180, which will be 0. This, and it will be 5A. So angle A equals 540 over 5, which equals 108. So the answer equals 108. SMO Singapore Mathematical Olympiad 2021 open section first round. Problem number 2020. Problem number 22. Find the number of positive integers n such that n of 7 and minus 16 divides n times 13 to the power of 2019. Okay, so let's use divisibility 7n. Let's write with blue. 7n minus 16 divides n times 13 to the power of 2019. 7n minus 16, if we multiply by 13 to the power of 2019 minus 16 times 13 to the power of 2019. So 7n minus 16 divides 7n times 13 to the power of 2019. So if we subtract 7n minus 16 divides 16 times 13 to the power of 2019. So 7n minus 16 will be what? Will be 2 to the power of m, because it divides it times, for example, 13 to the power of, we don't have k, to the k. And m is between, it is the positive case. Maybe 7 and n is positive, but 7n minus 16 is not necessarily positive. So we should check n1 and n2. In these cases, it is negative. 7 minus 16 will be negative 9. And negative 9 divides 1 times this, no. 7 times 2, 14 minus 16, negative 2. This, it divides 2 times this. So the one answer is here. I says find the number of them. So one answer here. Now let's consider when it is positive. So m is between 0 and 4 because it divides 16 times this. 16 is 2 to the power of 4, and k is at least 0 and at most 2090. So here, the only condition we have, this number is 7n minus 16, means mod 7 is negative 16. So 2m times 3 to the power of k, mod 7 is negative 16, so mod 7 is negative 2. If we consider this number mod 7, it will be 13 is negative 1 mod 7. It will be negative 2 mod 7, so we should consider two cases when k is even, when k is odd. Case 1, k is even. So 2 to the power of m mod 7 is negative 2, or you can say it is equal to 5 mod 7. But if we consider powers of 2, it will be 2, 4, 8 is 1. Again, 2, 4, 1. So we don't see 5. So here we don't have any answer. Let's consider case 2. When k is odd, so 2 to the power of m times negative 1 is here, negative 1 to the power of odd is negative 1 equals negative 2 mod 7. So 2 to the power of m equals 2 mod 7. So because here it is 2, 4, 1, 2, 4, 1, we can see that m mod 3 must be what? Must be, let me write mod 3 here, must be 1, because the period here is 3, and 2 to the 1 is 2, 2 to the 4 is 2. So the power mod 3 is 2. Now, here we know m is between 0 and 4. Let's copy it here, paste it here. Okay. Now, m can be what numbers? Can be only 1 and 4, because mod 3 is 1 and is between 0 and 4. 2 times k are odd numbers from 0 to 2019. It is 2020 over 2. So if we count all of them, we have 2020 numbers here. Also, we had 1 numbers here for n equals 2 and 7n minus 16 equals negative 2. So the answer is 2020 plus 1, 2021. SMO Singapore Mathematical Olympiad 2021, open section, first round. Problem number 23. In the acute triangle ABCP is a point and ABQ is a point on AC such that. So let me explain this problem on the diagram. Okay, so here look, BP, P is on what? AB, Q is on AC such that BP. plus QC plus QC equals, or CQ equals PQ. The bisector of A meets the circumcircle of the triangle ABC at the point R. So this arc equals this arc is AR is internal angle bisector of A. Suppose PRQ is 52.5 degree. Find the size of BAC in degrees. Okay, so let's see what can we do. In these types of problem, it is very important also use, this idea was used, I think, for IMO 2020, yes, geometric problem. When you have, for example, sum of two sides equal one side, one thing is to extend, for example, it is x, it is y, it is z equals x plus y. You can, for example, extend x, y, then sometimes also it happens like this. This x you extend here, so this will be an isosceles triangle. Another thing is that when you have x, for example, you have y here, and you have z equals x plus y, you subtract, consider x here, so it will be y. And again, we have isosceles triangle. So sometimes you should split up the largest side, sometimes you should extend. Also, these ideas are useful in angles. When you have, for example, three angles, one of them is sum of the other two angles, you can split one angle, the largest angle, or you can extend the other angle. For example, it is alpha, it is beta, some of them is theta. You can consider beta, so we have two equal angles, or split to alpha plus beta. Here we will use exactly that idea. We say, okay, PQ equals BP plus CQ. Now, we say what? We say, okay, BP is what? Around 0.48. Okay, it is this. Now, we consider this point and we call this, for example, T. This is equal to this, and because PQ equals BP plus QC, so this part equals, let me write with 3, this. Now, if we draw a line, let me draw with black, and this one, so here this angle is alpha, this angle is alpha, this angle is beta, this angle is beta, because isosceles triangle. So it is exterior angle is alpha plus alpha 2 alpha, and this angle is 2 beta, beta plus beta. So 2 alpha plus 2 beta plus a in this triangle APQ is 180. So alpha plus beta is 108 minus a over 2, which will be 90 minus a over 2. Now, if we connect R to T, so here we will see alpha plus beta is this. If we consider this angle BTC, angle BTC is what? Is 180 minus alpha minus beta. 180 minus bracket alpha plus beta. Here is 180 minus 90 minus a over 2. It will be 90 plus a over 2. Now also, if I is in center, BIC is also equal y. It's not hard to prove. Let me draw the figure here. That BIC, if we have ABC and BIC here, it is B half, it is C half. So BIC equals 180 minus B over 2 plus C over 2, which equals 180 minus 90 minus A over 2, which equals 90 plus A over 2. These two things are equal, so you can conclude BT IC is cyclic. Now, we know you can easily prove that RT equals RI. As I said, there are around 50 important theorems in geometry. If you had any question of that formulas, feel free to send message to my WhatsApp number. Here, also in the description, you can see that RI equals RB equals RC. So R is the center of BTIC. So we can conclude also they are equal to RT, because T lies, R is center of this circle, BIC and circumcircle PIC pass through T, R is center of that. So it equals also RT. So this is 1, 2, 3, 4 equals 1, 2, 3, 4 equals 1, 2, 3, 4. Now we can say, okay, R lies on perpendicular bisector of TC, also Q lies on perpendicular bisector of this, so we can say this is perpendicular bisector here, perpendicular bisector. So we can say it is theta because isosceles triangle. Altitude, this is gamma. So now the problem wants what? The problem wants BAC. So if you pay attention, 2 theta plus 2 gamma equals what? Equals, because A, B, or C is cyclic, equals 180 minus A. Also, the problem says what? PRQ. PRQ is what? Theta plus gamma is 52.5. So 2 times here is 2 theta plus 2 gamma. So 2 times this is 105. So we can conclude A equals 180 minus 105, which equals 75. So A equals 75. Let me prove this part for you, that y Ri equals Rb equals Rc. The proof only, you should use angle chasing. So if we have this, we have this, we have this. So consider it is I. I want to prove y Ri equals Rb equals Rc. Here it is what? It is a half. It is c half because angle bisector c half. It is equal to this part, a half, a half. So this is external angle here, exterior angle, a half plus c half. This angle is also a half plus c half, so this side, it is an isosceles triangle. Similarly, or we can say a half, this arc equals this arc, so the RC equals RB, so RB we proved equals RC equals RI, so we proved completely, and also I proved basic ideas that we need here to prove the problem and reach 75. SMO Singapore Mathematical Olympiad 2021, open section, first round. Problem number 24. Let S equals integral from negative infinity to positive infinity e to the power of negative 1/2 x squared dx. Determine the value of floor of S squared. The function here is similar to normal probability density function. It is what? F of x equals 1 over sigma square root of 2 pi e to the power of negative 1 x minus mu over sigma squared. So you should memorize this. And if you consider, we want to see here, sigma is what, mu is what. Sigma is a standard deviation, and it is a square root of variance, and mu is mean of these density functions. So we can say what here, if we consider sigma equals 1 and mu equals 0, so f of x in this case will be 1 over 2 pi e power of negative x squared over 2. Now, if I consider it's from negative infinity to positive infinity, because it is probably density function, it will be 1. So negative infinity, positive infinity, f of x dx is 1. So if you multiply both sides by root 2 pi, because it is constant, so it will be root 2 pi. It is what? It is exactly the thing we have here, for example, g of x. This g of x. So s equals root 2 pi. So s squared is 2 pi equals 2 times around 3.14. It will be around 6.28. We want what? Floor of s squared. Also, if you want to prove exactly, it is 2 pi. You can say it's less than 2 times 3, 115. It is what? 6 times 30. So because you want to find floor of that, The answer equals 6. SMO Singapore Mathematical Olympiad 2021 with section first round problem number 25. Let PQR be positive numbers with P minus R equals 4Q and A1, A2 and the other dot 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 and B1, B2 dot 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 be two sequences defined by A1P, B1Q, and for n greater than equal to an equals P times an minus 1 and bn equals qan minus 1 plus r bn minus 1. Find the value of limit and limit of this term when n approaches infinity. At first, we try to find an. An is a1 is p, so an over an minus 1 is p. So we can say an over an minus 1 is p, an minus 1 over an minus 2 is p, 2a2 over a1 is p. So we can conclude what if we multiply all of them? An over an minus 1 times an minus 1 over an minus 2 times a2 over a1 is p, look, a1 to an minus 1 p to the power of n minus 1. You can cancel all these things, so an equals a1 times pn minus 1. a1 is p, so an is p to the power of n. Now we want to calculate b. Look, b, here we have, if you want to use, for example, telescoping rule on, we can replace an minus 1 with this formula, but for bn minus 1, we have r. If we didn't have r, we could easily solve it by telescoping rule. But also, when we have coefficient, it depends. If the coefficient y here is constant, you divide by r to bn over r to the power of n. If the coefficient, for example, is n related to that, you should divide by n factorial. There are ideas of when we have coefficient also for other things, recursive sequence. There are some other ideas. If you want to learn all of them, as I said, feel free to send message to my WhatsApp number in the description here. Now let's consider write bn. Bn equals q times an minus 1 pn minus 1 plus rbn minus 1. And so we want to find b in terms of r. B in terms of r, p, and q. How? We say, okay, we define c equals bn over r to the power of n. If we divide both sides by r to the power of n, it will be q pn minus 1 r to the power of n plus bn minus 1 rn minus 1. So we have cn equals cn minus 1 plus q pn minus 1 rn minus 1. Now we can easily use telescoping rule. So we say cn minus 1 equals q times pn minus 1 over rn minus 1. Cn minus 1 minus cn minus 2 equals q pn minus 1 pn minus 2 rn. Let me check it again. Here we said pn minus 1 rn. Okay, so let me correct it. Pn minus 1 rn. Here it will be rn minus 1. And we write c2 minus c1 equals q times p to the power of 1 r to the power of 2 r squared. Now if we add all these numbers, then we have what? Cn equals c1 plus q p r squared. The first one is 1, the next one is p over r, and the last one is p to the power of n minus 2 r to the power of n minus 2. Now, if we want to calculate c1 at first, let's find c1. c1 is b1 over r. Now, if we want to find b1, b1 is what? Q. So it's q over r. So c1 is q over r. Let's calculate q over r times q times p r squared times 1 minus. So let's see the relationship between p and r. They are positive integers, so p is greater than r. So because p is greater than r, we can write pr minus 1 and pr to the power of n minus 1 minus 1. Now we calculate this qr here, we have plus. If we simplify, if we simplify here, it will be r squared times r p minus r and r n minus 1 p n minus 1 minus r n minus 1. Now let's simplify more. Cn equals qr plus. So if you multiply this r will be cancelled. It will be qp over r times rn minus 1 pn minus 1 minus rn minus 1. So it will be equal to this rn here qp pn minus 1 minus rn minus 1. Now we know what cn was bn over rn. Now we can multiply both sides by rn, so it will be qrn minus 1 plus qp pn minus 1 minus rn minus 1. Now if we write all of them, qrn minus 1 plus qpn minus qprn minus 1. I forgot here we have p minus r. Let's place it here, p minus r. And okay, so it will be p minus r when we multiply by rn. So let's correct this part. When we multiply by r to the power of n, here we will have this, and here we will have p minus r. So if we use common denominator, let's see what we have then. pqrn minus 1 minus qrn plus p plus q p to the power of n minus pqrn minus 1. So if we consider, they will be cancelled. It will be qpn minus rn over p minus r. So we found bn is what? Bn is this. So let's write the things we've written, we've reached so far. An is what? The first thing. An is p to the power of n. Bn equals q pn minus rn over p minus r, and the relationship between pq and r. P minus r equals 4q, p minus r equals 4q, and the last term is find limit of this function. So now let's focus on finding limit here. Okay, so because here we can say p minus r is 4q, we can replace here, so we can say, okay, bn equals pn minus rn, q is 4q, so it will be 4. Now, in this case, we say, okay, because bn is positive, we can prove easily because p is greater than r. So we take bn inside, it will be an over bn squared plus 9. And let me write limit in front of that and approaches infinity. So it will be limit n approaches infinity an over bn. So it will be what? It will be 4pn over pn minus rn squared plus 9. So we should focus on the thing inside here. 4pn pn minus rn. If n approaches infinity, you divide it by pn, both numerator and denominator. It will be rp over n. We know that because q is all of them are positive and p minus r is positive, so p is greater than r. So here it will be 4 over 1, which will be 4. Now, in this case, we will have 4, this part is 4, limit of this, we can get rid of that. 16 plus 9, because 4 squared plus 9 equals square root of 25, which equals 5. So the answer equals 5.